Okay, in this last example, we saw how we were going to take zeros and then build a polynomial from that. Now, I just wanted to say a little bit more about this because it depends on what book you're using and where you're at. But a lot of times, especially if you check answers in the back of the book, it'll say, this is the polynomial for a equals to 1. And I wanted to show exactly what that was talking about. Remember, in a quadratic especially, your a value is the number that's in front of the x squared term, right? It's ax squared plus bx plus c. Well, let's look at how these two functions that appear very different are actually going to turn out to have the exact same zeros. Okay, if I were to try to solve this first one, find the x-intercepts, then I would start out by saying 0, replacing the y with 0, equals 3x squared minus 12x minus 15. Now, since this is quadratic, we have to think factoring. And our first rule of factoring is always to pull out the GCF. So that would be a 3 in this case. If I pull a 3 out, we have 3 times x squared minus 4x minus 5. And then to continue on, we could divide both sides by 3 to get rid of it. And we would have 0 equals x squared minus 4x minus 5. From this, then, we could continue factoring and solving. But I want to take a minute and go back up to this next problem. Here again, same situation. If I were finding the x-intercepts, I would let y be 0. So that would mean 0 equals 2x squared minus 8x minus 10. And then quadratic, so that means we're going to factor. I'm going to pull out a 2 here. So this will be 2 times x squared minus 4x minus 5. And if I were to divide both sides by 2, then we would have 0 equals x squared minus 4x minus 5. These now are the exact same to be finding x-intercepts. So even though our a value was different, our equations are going to virtually look the same. That's what this is talking about. So if we were to work this problem, we're essentially saying that we're calling a 1. We could have put a 3 in here, and it would still be a function that's a degree 3 polynomial with these zeros. They're just saying that to make it easier, we're just going to say a is 1 so that we all have the exact same function and nobody gets fancy and puts a million here in front, which would still have these same x-intercepts.